Hi there, this is Mrs. Sharp, and I just wanted to go through a couple of examples of drawing some Lewis structures with you, either if you weren't here Thursday or you just wanted a couple more examples of some Lewis structures. So I'm just going to go through the steps here with a couple more compounds until you feel more comfortable, or like I said, if you weren't here, to get the general idea. So there's some steps for drawing Lewis structures, and Lewis structures are basically a picture of what a covalent molecule would look like, the arrangement of atoms. And let's do, for our first one, let's do oxygen difluoride, OF2. So oxygen difluoride, first step would be to determine the number of valence electrons each atom has. So for our oxygens, we only have one oxygen in the formula, and each oxygen has 6 valence electrons. Remember, that comes right from your periodic table. For fluorine, there are 2 of those in the formula, and each fluorine has 7 valence electrons. So altogether we have 6 plus 14, that's 20 valence electrons. And that number is really important. We need to make sure that when we're done in our drawing, we have exactly that number of valence electrons, because that's what we actually have. Step 2 is to determine the number of valence electrons each atom wants. So in this compound, if oxygen was perfectly happy, that one oxygen would really like to have 8 valence electrons. The 2 fluorines would also like 8 valence electrons. And remember that you're going to have a lot of times 8s in this want step. Everything is times 8 except for hydrogen, which would be times 2. Okay, so if I add those all up together, I'm going to get 3 times 8 is 24 valence electrons. So that's what I need to make these atoms feel like they have. But remember, I only have 20 electrons to do it, so I need to make 20 seem like 24. And the way that I'm going to do that is by sharing. So I'm going to subtract those 2 numbers to find the number of valence electrons that must be shared. So that's 4, which means as far as pairs go, we're going to be sharing 2 pairs. So when we're all done and we look at our molecule, we should only have 2 shared pairs. In step 5, we're going to place the least electronegative atom in the center. Well, we don't have H, so we don't need to worry about that. If I look at my electronegativities, I see oxygen is 3.44 and fluorine is 3.98. So oxygen is definitely going to go in the middle. And fluorines are going to go on the outside. Now remember, it doesn't really matter where you put them. Just distribute them so that the O is the center and you think of them as like spokes coming off. Number 6 says to distribute the shared pairs between atoms. So we had this in our last step, and we had 2 shared pairs according to number 4. So there's a shared pair 1, keeping those 2 together. And we'll put a second pair right here between those 2 atoms. So there's our 2 shared pairs. We haven't made anybody happy, because to do that we'd need to make everybody feel like they have 8. So fluorine right now thinks it has 2, he's not happy. Same with this one. And this oxygen thinks it has 4, not happy. So we'll move on to step 7. Step 7 says to use lone pairs to make sure that all atoms satisfy the octet rule. So currently what we have are 2 shared pairs. That means we need to use the rest as lone pairs. So we'll start with this fluorine. Fluorine has 2, so that means it needs 6 more, so that would be 3 lone pairs. So go ahead and circle fluorine once he has the correct number of valence electrons, which is 8. Well, this fluorine has 2, so we're going to also need to add 6 electrons, or 3 lone pairs, to that fluorine. This oxygen thinks it has 2, 4. So we're going to add 1 lone pair on this side and 1 lone pair on this side to make a total of 8. Now, as you can see, I have 2 shared pairs, 1 here and 1 here. And I have not, number 8 says to double check the number of electrons from number 1. And they should match. So in other words, I should have exactly 20 when I count up how many electrons are in my diagram. So 2, 4, 6, 8, 10, 12, 14, 16, 18, and 20. So since I have 20 and it matches number 1, I have drawn this little structure correctly. Now if I was going to do the structural formula, I would replace any shared pairs would become dashes. So with my O, I would replace this shared pair right here with a dash to represent a shared pair or a bond, a single bond in this case. Same thing to this F. We're going to continue to use our lone pairs, and we need to remember to put our lone pairs on our oxygen. So that's called the structural formula. Okay, let's go back and do another one. For example, let's do, I'm trying to think here. Let's do hydrogen cyanide, HCN. So let's determine the number of valence electrons each atom has. So hydrogen, there is one of them, and hydrogen has one valence electron. Carbon, there's one of them, and it has, whoops, this should be a times, has 4 valence electrons. Nitrogen, there's one, and it has 5 valence electrons. Altogether then, that's 1 plus 4 is 5, plus 5, I have 10 valence electrons. So remember, we need to check that when we're all done. Step 2 is determine the number of valence electrons each atom wants. So we'll start with hydrogen again. There's one of them. Hydrogens, remember, only want 2 valence electrons. That's the only exception to the octet rule. Carbon, there's one, and carbon would be happy with 8. Nitrogen, there's one, and it would be happy with 8. Okay, so I erased this before I meant to, but if hydrogen wanted 2, and each of the other 2, my carbon and my nitrogen, wanted 8, then altogether that is 4 plus 8 is 12 plus 8 is 20. So I need to make 10 seem like 20. So this is kind of a taller order than the other one. So when I move on to step 3, when I'm subtracting, I have 10 valence electrons that must be shared, which results in 5 pairs that need to be shared. Which makes me feel like I did something wrong. That's what I did wrong in my last slide. Okay. So see, even Mrs. Sharp messes up sometimes. Hydrogen is only one, but wants 2 valence electrons. There's only one hydrogen in this formula. I apologize. I hope that didn't mess you up too much. So since there's only one of each thing, there should be 1. So it'd be 2, 10, 18, not 20. Okay, so that means we're not doing 20 minus 10, we're doing 18 minus 10. I'm sorry. So that is 8 valence electrons, and 8 divided by 2 should be 4 shared pairs. So sorry. Okay, but at least we got it straightened out. So here we go on to step 5, and I'm just going to do 5, 6, and 7 all together on this slide. So I'm going to place the least electronegative atom in the center, never H, so that's between C and N. So C is 2.55, N is 3.04, which means C is going in the middle, just like it is in the formula. And I'm going to go ahead and just, since I have 2 other atoms, I'm just going to put them around evenly. And remember, I have 4 shared pairs now. And that's what I need to distribute first. So I'm going to go ahead and I'm going to do 1 shared pair in between each. That's 2. And I have 2 more that I need to go on. But this hydrogen is done. He only wanted 2, so I can't add any more to hydrogen. So the only place I can share pairs is right here. So the remaining 2 pairs need to go right here between carbon and nitrogen. Once I've done that, this carbon now feels like he has 2, 4, 6, 8, so he's happy too. So when I get to step 7, using lone pairs, only this nitrogen still needs lone pairs. He thinks that he has 6, so I'm going to add 2 more to make 8. And he should be all set. So I go back 4 shared pairs. I've got 1, 2, 3, 4 shared pairs, just like I said I did. And total electrons are 2, 4, 6, 8, and 10, just like in step 1. If I was going to do the structural formula, remember I just replaced shared pairs with dashes. So I'm going to have a dash to H, and I'm going to have 3 shared pairs, so 3 dashes to N, and then of course my lone pair on the nitrogen. So I hope that helps a little bit if you're having trouble with loose structures. Of course you can come to me with any other questions you have. Best of luck. Have a good day.